So now I cleaned the little hinge point of the tape tension lever, so it's all moving very easily. It's this lever over here which was stuck. The threading mechanism can be run by putting power to the third and fourth contact here. So I use a 5-volt supply with a 10 ohm series resistor, so I cannot overload anything. When something gets stuck or something, the motor will be torque limited. Not easy with one hand. So I took off the shield from the CCD boards. There is this shield which is soldered with wires at 2 points. On this side of the board it has the SMD capacitors, and it's full of this brown gooey electrolyte that has leaked from those capacitors here. And this board is double, so it's packed with capacitor at this side, which I don't spot any leakage. So, and this board, it contains the CCD chip, and I'm not sure if I can take it apart very easily and without the risk of damaging it. So, and I spotted one of the motors. There is a zoom lens motor and a servo motor and diaphragm motor. And this one, it has you see the belt, it's gone. Yeah, it's back there behind somewhere. It's the belt came apart, and it you know, it got like liquid. So that's about the board on the lens. Then there's at the side of the lens this little package with a DC converter. It's soldered closed around, so I desoldered it so that it came apart. And this board is also packed with capacitors, and the one that is very leaky is this one here. This thing is zooming perfectly, focusing. It's all corroded there, so I need to replace those SMD capacitor and SMD resistor that got damaged by the acid coming out of this one. So okay, this is the converter. Then we've got the servo board and the video board, and the problem started. It's not SMD capacitors, it's all through hole. And here you can see the brown acid coming through the board. This is another DC-DC converter, I believe. So I turn around the board now to see this leaky capacitor. So that's the other side. This one, and it has bulged. It's a 47 microfarad that leaked through the board to the other side. So yeah, and those three are for the capstan motor. They look like they have leaked. Those three are for the head drum motor. I think they will be loaded some more with AC component than the other capacitors, and yeah, have to do harder work in their life and become damaged earlier. So I have to see. I think I'm going for tantalum capacitors there, which hopefully will be more reliable. And this is a bridge I needed to make because of the acid in this metal shield. Below the shield is some trace that got eaten away by the acid, so that's this the initial problem. So I removed all electrolytic capacitors. You can see here the solar pads are luckily very intact, and I ordered some new SMD tantalum capacitors. They have a little bit lower ESR than this drop type tantalum, and since the original, this one is an electrolytic capacitor, it has a low ESR, so I thought let's replace it with low ESR. So you see these legs, they extend to the middle of the capacitor, but from the top, I mean when it's like this on the PCB, you can only touch your soldering iron at the side. Now you see that leg here. You can only touch it at the side, so you need to take your time. Take the time for the heat to get from the side all the way to the middle. So that's the side you can touch with the soldering iron. So, and that's the middle, so you need to wait until the heat gets all the way to the middle. And then lift it one side, heat up the other side, and then you go like this a few times, because if you pull too hard, you will break the soldering pad. And for example, you see here beside the soldering pad there is this hole that goes to the other side, because it's a double-sided print and it's a connection to the other side. Now, because of these holes are near the soldering pads of a leaky capacitor, the traces got black, they get corroded. So you see here I made a little piece of copper wire, and it's very thin. I mean, this is on my finger. I used one strand, just one strand of this wire, and also here this solder pad, it got right beside it this hole to the other side, and that was black, corroded. So I made here again one strand. I put it all the way through the hole and connected it on the other side. So it was still conducting, but since it was black and eaten away half, I thought let's make it a little bit proof. Also here, connection to the other side. Now I cleaned this, it was all full with electrolyte. I cleaned it the best way I could using this earbuds with some brake cleaner that dissolves it pretty decent. But yeah, the stuff, it got an old potentiometer, so I hope that those didn't damage. And at the other side it leaked to that square IC between all legs is the electrolyte of the capacitors. So I cleaned it. I used a knife like this to get it out of the pins and some brake cleaner, but yeah, it's not completely clean, and I don't want to know what's below this IC. Maybe it's, yeah, full with eaten away traces, so I don't know. And this is the actual CCD chip. It's on this board. So yes. So now I'm going to put on those, I bought all kinds of tantalum capacitors and I made some boards to put them on if I need to make a true hole version of it for the other board. But yeah, I hope I can just drop them right in. And yeah, please pay attention, because the original has the marking on the minus side and the tantalum has the marking on the plus side. So yeah, that's the difference. So here in this board, capacitors are replaced. Not the cleanest job, but for example this one I didn't have the room. The pads were so close together that I couldn't do it all straight. All the bad electrolytics. Also here on the servo board, below that cap is the pulse width modulated power supply for the capstan and head drum motor. So I put the tantalums in there. Some traces going through this shield and got eaten away by the acid of the capacitors. So those three of the capstan motor replaced. So because of the eaten away traces, I made here some jumper bridge wires. Also there a little wire bridge. This is the back side of the pulse width modulated power supply. I replaced this capacitor and this resistor because they looked very corroded. So, and here my zoom motor is running again, and the focus motor is working again. I found this is the original belt, which is a little bit too loose, and the other one was like liquefied. I found this rubber belts to put in your hair, and they're a little bit too thick, so I put them around the screwdriver and used the Stanley knife to cut them in half. So those are the half. See how thin that is? They're like half the width of the belt. So yeah, that's all working. So let's put this thing together and see what happens. So I found I even have the manual of this camera. I bought it second hand at some point 20 years ago with a defect, and I forgot I got the manual with it. So it even has the bills of former repairs with it, and this is one of them. It is 227 guilders back in 2000, and it says there was a problem with the tape path, readjustment of the tape path. So yeah, I put it back together, and so those are the capacitors that came out and the new ones that went in. And since there are so many bad traces, I didn't expect it to work, and it's also not so easy to have a service position with this thing, with everything connected and with it opened up. So yeah, I just put it together hoping that it would work. It's not really a professional way of doing it. But yes, this is the camera section. So yeah, that is just a nice picture. Can I show you the viewfinder? So the pattern generator was also all bad. I got all kinds of characters, and now it just says stand by. And you can get the can you see that the date at the bottom of the screen. There's the date, like this old home movies had. So yes, and my elastics for zooming are working. Yes. Then autofocus is working. If I take the whole thing up, see, it's searching for the focus point. So that's all working, and then the recorder section, I'm going to show that right now. Something I recorded yesterday. So yes, let's see, we're gonna have still picture. Fast forward. Reverse. So yes, it's looking good. All tape transport functions are just working fine. So, yeah, pretty pleased with this. I've got the belt with it. It looks pretty decent. The cap is still there. Yeah. So, that's working.